Assalamualaikum warahmatullahi wabarakatuh. Yeah, hello everyone. I'm Myanmar. Today, I want to talk about molecular dynamics simulation of our molecule under the two solvent condition, vacuum and the solvent. So the first, between the simulation stage, the first, selecting a small organic molecule before a level of chemistry, biochemistry, pharmacy, or natural product. So, I choose eugenol. It is a major component of clove season oil, exhibit antibacterial, anorgastic factor reducer, and fermentor. And then the last is antioxidant properties. And then the next open chemical application to patch and then the function CID. The function CID is 3314. Okay, the next click action and then click on all bonds and choose a ball and stick and click check again and click label and choose the one. So the next you click post structure editing and just minimize structure and click minimize and okay 3 times to get a nice structure of minimize and then you click close and then the MD and sample analysis and choose a molecular dynamic simulation and then we have a two simulation parameter. There's our vacuum condition and then a condition with a solvent or water. So the we got first parameter. The first is parameter vacuum condition is not a half a solution. So the first click the run parameter and then run parameter set the step as the scan step is 200 to 1000 200, sorry. And then next, check they set the minimization to equilibration, and then the equilibration to introduction to change. The output trajectory file and to the standard story file. Uh, put the file we want to from C until the next call. So the result click run. After after it is a result after the running, and then click the file, record the movie, and press file or when to save. And then open the white infer or recording animation. So the next, it is a result and the vacuum condition is original. After this is a consisting of uh, 1001 frames capture. The representation motion of molecule in real time, moving the molecule are dynamic in state, not a static one. Okay, it is a result of from one. Okay, it is a result of the firm starting to stabilize. Although there is only for the firm one is zero, the strong stability is zero molecule begins to be as if and passing through the equilibration phase. This around the frame 200. At which point the physical fluctuates begin to stabilize within the range of 1.1 until 1.3 Armstrong. Next, the frame starting to stabilize the low energy is potential energy. The lower potential energy value, the less time there is the molecule. You can see the lower value in the frame 208. Okay, on the next is the stabilized in kinetic energy. Kinetic energy is reflect the thermal attitude of the atom stability for the system is indicated by consisting kinetic energy value. It is around from 5 until 500 and 10, suggesting the simulation has reached a stable configurator and accordance with the specific parameter. Okay, the next simulation is the solvent mode aqueous. So these are some step before. So it is a result again with the solvent with water. In the interaction with water, the catalyst surround the external molecule. So it is a result from one. So it is a result also stabilize RMSB value. The structural stability passing through the equilibration test are from 400 until 418. At which point the physical fluctuation began to stabilize within the range around that of zero point 0.8 Armstrong. And next, this potential energy. Potential energy value dilastaran the intermolecule. You can see the log value on the firm one. It is the potential energy is minus 4,000. Okay, the next is kinetic energy. It is around the frame 10 until 400 419. Is the stimulation has a result, stable temperature outcome then with the specific parameters. So what is the interpretation of the result? So during the molecular dynamic, the simulation of a genome rotation occurred. The signal bond, particularly allele group and metoxy group. So we can later to report movie, the molecule continues to move and find the position with the lowest direct hindrance. So the next is a change in the position of atom external group. This is a relative position of the carbon atom, the benzene ring, remain fixed often when the coordinates change, but the position of the hydrogen atom, the allyl group undergoes significant shift. Next is structural flexibility. The journal has moderate flexibility. Somatic ring is very rigid, whereas allyl side chain is most flexible and mobile part. On the last is large negative value in the with the sulfur and with vacuum. We can see the potential energy. The with sulfur is a very negative value. So this occur due to non-covalent interactions and again bond between the hydroxyl group of a journal with the water. So thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.